Everybody, it's Eugene Licio here, and welcome to Click 3D. This is the program where we talk about photogrammetry, we talk about 3D scanning, laser scanning, and all things 3D, like documentation, analysis, and different types of visualization. Now, on today's program, I'm going to be having an interview with Chris Ahern from DotProduct. But before we do that, I wanted to talk a little bit regarding structured light scanners, and more specifically, some of the lower cost sensors that you can get online these days. And so, for example, Intel is making some of these RealSense sensors that are quite interesting. And even going back in time a little bit, we have the PrimeSense sensor, which is now, I won't say it's outdated, it's still a great sensor, but just there's a lot of sensors that have come about since this was first released. But let's talk about hand scanners and why they are useful. Well, one reason is, of course, they're light, they're small, and they're portable. So that's super useful. You don't need a big tripod. You can just kind of carry them in your hand. And in fact, nowadays, if I grab this, you'll see that I can use just my phone and a sensor here, and then I can go around and scan with just a very, very simple setup. So I just use a regular little mini tripod and sort of a cell phone adapter or holder, I should say, and that's it, plug it in and go. But really, the actual scanner here is my phone and this sensor. So between those two things, that's all I really need. Now, the other thing is the cost. So a lot of these sensors are fairly low cost, on the order of a couple or few $100s. So they're not thousands and thousands of dollars. So they are within reach for most people or companies or whatever that need to do some, quick scanning. Now, on the downside, though, the accuracy is not like super, super high. So if you're looking to document things for, the aerospace or automotive or whatever, you're probably going to need a different type of scanner. So this is not the right one for you. But for many things like construction projects or simple measuring, you want to take a model of a car or of a room, of a house even, on the interior or floors and that sort of thing, it's no problem. I mean, so long as you're willing to accept, a centimeter or a few centimeters of accuracy or error, then it's absolutely fine. So let me run through just some of the sensors here and what I've got. And maybe what I'll do is I'll go through them in a kind of chronological order. So the first one that came out way back when was the PrimeSense series of sensors. And this was, PrimeSense was from an Israeli company that was founded in about 2005. And they really hit the market big because they partnered with Microsoft. And so their technology was inside of the Kinect, the Microsoft Kinect that was used for gaming and that sort of thing. And of course, those types of sensors and that technology was adapted to different types of 3D scanning systems or vision systems. So there were two sensors that came out. One is the version 1.08, 1.09. So one is like their regular version, let's say, and one is a short range version that was for shorter distances and that sort of thing. But the sensor is still great by any standards. Today for interior, doesn't work all that great outdoors. Okay, so you can capture very little data, but it has a lot of problems with strong sunlight. So if you can imagine, the sun is emitting all types of light, infrared, X-rays, and everything else. And so it's kind of like having a flashlight on during a really sunny day. You really can't see the flashlight. It kind of gets mixed up with all the bright sunlight. Now, from there, I should say, Intel released the PrimeSense series. And I'm only going to be talking about two or three here, but this is one, this is the 415, so the D415, and this is an interesting sensor. It's good to about 3 meters, okay, from about half a meter to about 3 meters, and it uses a type of stereoscopic structured light. So there's an infrared projector, there's an RGB camera, and there's basically an infrared camera that's detecting the pattern. And what I'll do is I can show you what the pattern looks like here. I did a recording just before, so I'll let that roll. But you can see it's like a sort of a grid of dots, and it's kind of interesting. It's stationary, but it basically detects the distortion in the pattern to create 3D. Now, in terms of accuracy, this is something, the way that they're reporting this is like 2% at 2 meters, okay? So it depends on the distance, okay? So, it's not too bad. I mean, a couple centimeters, but, there are ways through software and algorithms to improve on that a little bit. The type of light that's being used here is that it's a laser projector, and it's in the range of 850 nanometers. Now, the other sensor here is, this is the Intel D455. And this is kind of interesting, kind of the same thing. Also good for indoor and outdoor. And I don't know if I mentioned that on the D415, but it's also good for outdoor. So it has a slightly different method here. It actually uses a stereo kind of method for the pattern. So when the infrared pattern is getting bombarded with sunlight, it reverts to a type of stereo, or almost like a photogrammetry method is what I'm imagining here. But this particular sensor is better for longer ranges. So it's good up to about 6 meters. And the accuracy here is reported as 2% at about 4 meters. It's a little bit larger, but again, like really small, something, you can still fit it in your pocket or in a small device. It also has the same wavelength. So this one is using 850 nanometers, which means that it's way above what we would normally see. Now, let me bring up another one here. And for this, I'm just going to share my screen here. So just give me a second. And what I want to do is I want to show you the Intel sensor, which is the let me go to the window. It's the 415. So that's the the L515. Okay, so it's this little puck. It's a little puck thing here, and it's not a structured light scanner in the same way. This is actually a solid state LiDAR. And so what that means is it is in fact emitting, lasers, and is trying to detect the time of flight, basically how long it takes for the light to come back. And from that, it can, determine the distance and create a 3D model. Now, this one actually indoors has a really good range. So it goes up to about 9 meters. It has good accuracy, but it's not good for outdoors. Okay, so as soon as you get into bright sunlight or a little bit of sunlight, it causes some problems. It is relatively small, so about the size of a hockey puck or something like that, and has a similar wavelength. It's about 860 nanometers in for the wavelength that it uses, and it's eye safe. It's a class 1 laser, which means that it's not a super powerful laser, and it's safe for you to let's say look at, or if it happens to cross your eyes, it's not going to do any type of damage. So these are basically the family of sensors here that is being used by DotProduct. And so I did an interview with Chris Ahern, and it's really interesting because they're doing a lot of good things with these low-cost sensors, and a lot of it is happening in the software. So the technology that they have in the software is really, really important. So let's go over to the interview that I did with Chris, and we'll leave it at that. Thanks. Hey, Chris, thank you very much for being here today. I'm really interested to hear about the DotProduct offerings.
Thanks for having me, Eugene. My pleasure.
All right. Maybe we should start with your background. We met probably like 4 years ago, and you do a lot of stuff at DotProduct. So what is your official title?
I'm a VP of Sales and Marketing here at DotProduct. So, among other things, in a small growing company, I head up our sales and a lot of our marketing efforts. So I'm doing a lot of our video sample data collection and product testing, as well as working with our sales team to get this across the globe.
Yeah, man of many hats here. I know that for sure. So can you give me maybe just like a little bit of background on the history, just very briefly, like the history of how sort of DotProduct came to be? I mean, I know some of the players in the company or whatever, but just for some of the people that are going to be watching this.
Absolutely. So I wasn't quite here at the very start myself, but within a couple of years I joined. So I've been here for quite a while along the road. And at the very beginning, it began with our CTO, Raphael Spring, who is the original founder of the company. And he is a computer vision expert. So he had a real expertise in understanding how today's computers can really sense and see the world using the increasingly powerful depth cameras that are available. He connected with the other founders of the company who came from a background of traditional laser scanning or tripod terrestrial scanning, and kind of had an understanding of where 3D data capture was already being deployed across industries, and kind of how there was this significant gap in the market in terms of something that was more portable and easily deployable. So they knew the market, he knew the technology, and that was what launched our first DPI kit, which was a full package kit of a tablet-based 3D capture solution.
Excellent. So I think what I'd like to do is kind of go through the sort of the different types of offerings that you have. So, for example, look, maybe we'll talk about the different sensors if you can,
Sure.
and then I wouldn't mind talking about like the different types of kits and things like that. But maybe let's start with the sensors because that one really interests me.
Absolutely.
Maybe we can do them in kind of chronological order, like where you started, because like I've got this one here. I guess this is the DPI 8X,
Yep.
and so the PrimeSense sensor was that the first one that you started with?
It was, yes. And believe it or not, to this day, it's still one of our top of the line cameras. It's a really powerful camera that has been on the market now in various forms for approximately close to 10 years. And was designed for a variety of applications from gaming to robotics, just like every camera we use. They're not specifically designed for 3D scanning. Could be depth sensing, could be augmented reality. But we found our niche in terms of utilizing these cameras for 3D data collection. The first one that we implemented was the PrimeSense. And we've developed our own proprietary methods of calibrating these cameras to achieve very high levels of accuracy. Our software in the post-processing can improve upon that even more with all the cameras we use. But a DotProduct calibrated PrimeSense is sold in a packaged housing, which is a DPI kit. The very first one was a DPI 7. And we've improved upon that several times over the course of our existence. So the next was the DPI 8. And those numbers kind of align with the tablets getting a little bit larger and a lot more powerful. So we went from an HP Slate tablet to an NVIDIA Shield. The DPI 8X that you have is when we converted to a much more ergonomic and practical rugged housing with the dual grip. Then we moved on to Samsung tablets from there. We've had a couple different options in that world, introducing HD photo capture. And with each of these tablets, increasing the size of each of the scene you can capture because of better processing and more memory. So the very latest model is now operating on a Windows or Android platform. That's called the DPI 10.
Okay. So the PrimeSense, so the very first one, obviously it's I mean it's still being used today. So it means all the with the evolution of the software and everything else, it's still being used. But there were two versions of that initially. Is that correct?
Yes, and that is still the case. So short after the original PrimeSense came out was the 1.08. They came out with the 1.09, and the difference there in terms of applications for us is a longer range and a shorter range version. So across the existence of each of these, PrimeSense based kits, there's been the standard version and then the SR version. So today that translates to a DPI 10 or a DPI 10 SR. Same would have been for the 8 and the 8 SR. The range on the DPI 10 is 2 to 12 feet or 0.6 to 3.7 meters. And the range on the SR version is 1 to 6 feet or 0.3 to 2 meters. And that really just breaks them up into different applications. If you're scanning, in a household example, a piece of furniture with trying to get as much detail as possible, the short range version is going to be much better. If you're trying to scan a whole house, the long range version is going to be much better.
Okay. Can we talk about the RealSense, the Intel RealSense sensor? So
Absolutely.
I've got a couple here, and I've got to say, like, one of the things I love about this is just how small it is. So, this is my phone, and I just got a small mount, and I put the little thing up on here, and I had Velcro on the back, so I could just stick it on the back. And I mean, if you've got, I don't even need the if I got the phone and the sensor, I don't even need the tripod. I mean, it's like you can literally slip it into your pocket, right? So that's kind of cool. But there are 3 sensors. Yeah, you got it there exactly. This particular sensor, was this the first, like, in terms of RealSense, like, when was it introduced, and maybe you can talk about the evolution of those and some of the benefits and such?
Sure. So we've been involved with RealSense from even before they were, official, from the very, very beginning. Intel are lead investors in our company, and we have a lot of synergies in terms of that partnership. So the very first pass at RealSense were actually embedded cameras built into some of their two-in-one type laptops, things along those lines. it was an exciting first step, and it kind of put us on that trajectory. That was the R200 series, R standing for rear facing, because a lot of times some of these cameras are being designed for front facing, for facial recognition, for Snapchat filters, things along those lines. It's the rear facing ones that are exciting for us to see the world and capture the world. The R200 did, though, leave a lot to be desired. And that's when they moved on to the D400 series of cameras. And we've seen a lot of exciting things happen with those cameras. And by and large, the first camera that we really supported, carried, and sold ourselves with a lot of success was that D415. And the biggest thing for us there was it was the first camera that we supported that could work in outdoors, even in bright direct sunlight. For a lot of the infrared, even the LiDAR cameras we support, sunlight can be a big challenge. So this is an exciting step in that direction with the D415.
Yeah, so I bring this on me with vacation, and I remember the first time I tried this outside, I actually did my car, and I was in a parking lot at the university, and I went around and I looked up, I said, holy mackerel, like I got data from this thing. Like I couldn't believe it, right? So, which is different than this one, like in really bright sunlight, it suffers, right?
Exactly.
So, yeah, that was a great advancement there.
Yeah,
so then they have, I mean, Intel has a whole bunch of these different sensors, and you've obviously picked some of them to really focus on. So after the 415, what's the next one that you evolve to?
So we actually do support the next step in that line, which is the D435 and D435i. However, in our testing, we found that the 415, even though an older camera, was still a superior option for 3D capture purposes. The 435 had benefits maybe for sensing, field of view, robotics, but the 415 was still our leading candidate there. So we really stuck with the 415 for quite a while. Although we, like I said, do support the 435 as well.
So was the 435, was it because it was more sensitive to sunlight outside, or was there an accuracy issue? What was the main issue?
The main issue was accuracy. I mean, it's still, you could still plug and play, capture some good data, but at the end of the day, the 415 was giving us higher quality results. So that was what we recommended. Not to mention the 415 is an even more affordable camera, which if you buy direct from Intel is only $150. So really exciting step in that direction of not just small form factor, but like very deployable price point for these cameras as well.
Okay, cool.
So we do support, that whole 400 series, but primarily it was the 415, and then last summer, almost consecutively, a couple months from each other, they came out with two new cameras. One was the direct successor to the 415, which kind of combines the best aspects of both the 435 and the 415, and that's the D455. So it's a little bit larger, so that longer separation gives you more accuracy, and longer range, wider field of view. So it's kind of improving upon the 415 in just about every category. Still coming in at just $240. From Intel, so incredibly affordable, and capturing some really, really good data. And all of this 400 series, are using similar assisted stereo scanning technology. So that's why they are able to scan out in sunlight. They're not as reliant on the infrared for the depth calculations as the PrimeSense is, for example.
I see. Okay, cool. Obviously you provide these options, and is it easy to switch between the two? Can you use both? Are there advantages for switching these?
Yes, you can definitely switch between multiple cameras. And that goes across the board, not just between RealSense cameras, but also between a DPI or a PrimeSense camera. So for example, one of our webinars over the past year, we scanned an interior space using the L515, which we haven't really talked about yet. That's the RealSense LiDAR camera. And then we switched in the same scan file, same scene, to a D455. Then using the append capability in Dot3D, relocalized with the outdoor capable camera and walked right out the door. And then you had a single file that was captured using two different RealSense cameras. And you, of course, would not have been able to get that data outside with the L515 or even with your DPI.
Oh, awesome. Well, I'll tell you what, let's talk about the L515 then, unless there's something else in between.
Nope, not exactly. No. So I can, just highlight as we've been talking about here. So here's the D415. This was the first one in many regards. Then side by side, you'll see a little bit larger is the D455. This is the successor and improvement upon the 415. Both of these excellent outdoor capable cameras, very affordable, available from Intel or with added calibration from DotProduct for improved accuracy. The only scenario I would say where the 415 is actually superior to the 455 is in terms of outdoor sunny and the color of the data. Sometimes the 455 can have a pink or a purple tint to it, but you're benefiting longer range, wider field of view, more accuracy. So it's really doing great, but it does have this tint sometimes. 415 doesn't have that. So if you want really pretty picture looking outdoor bright sunny data, maybe you would still go with the 415. But the question at hand is the next one here, which is the L515. So notice this looks a little bit different than the 400 series. It's because it's a different technology. So this is the first true LiDAR camera that we've released full support for in Dot3D. And given that it is LiDAR, it is inherently very accurate. It's clean, crisp data. You're going to get less noise, less fluctuation in the data, even in its unoptimized format. And it is the longest range camera that we support as well. So this can see up to 20 feet at any point in time in a fully indoor scenario. So it's not an ultra, high strength LiDAR. So it is still an indoor only camera, and actually more so even than the PrimeSense or the DPI. So significant window lighting and challenging surfaces can be a little bit problematic for the L515. But that being said, it's an extremely affordable and effective LiDAR camera, $350 camera from Intel. And because it's LiDAR and so accurate in its own right, it doesn't even need any added calibration. So whether you buy it from us with a magnetic mounting kit or you get it directly from Intel, you're not missing out on anything either way. And for fully indoor applications, it can get long range and high accuracy. It's also unique in that because it is LiDAR, we have a mode in Dot3D where you can use it even in a pitch black situation. So you could be scanning outside even without any added lighting using the LiDAR, and it'll even recognize targets and give you a grayscale version of your scan, even in pitch black.
No, that's awesome. That's cool. Let's talk about the kits maybe, because
Sure.
excuse me, you package these in different ways, and I've noticed now you have like a smaller module now, sort of like a version that you could attach on something else. So can you kind of run through some of that?
Absolutely. So first off, I'll show you, similar to what you have, how the DPI kit comes. This is our complete package solution. Comes with the whole rugged carrying case. With your DPI cameras, DPI 10, I should say, the tablet slides and locks into place. So this is like a complete package solution. You pay a little bit of premium for it, but it is really, a really powerful complete package way to go. Your camera's built in. If you want to use a RealSense with these kits, you can magnetize them right to the front or take your tablet out and magnetize them to the back. Recently released the new DPI X kit, and I don't actually have that in front of me, so let me just pull up an image of it.
What's different about this one?
So it's a little easier to show. So it's the same camera. I believe you should see my screen now. This is just from our website, but it is modular. So this is basically leveraging the success that we found with RealSense cameras, where people are like, it's affordable, it's small, I can click it onto my phone, I can click it onto my tablet. And it also avoids compatibility issues. So the DPI 10 kits, are in some ways specific to certain tablets that slide in, lock in place with each of these custom designed housings. Whereas with the new DPI X, you can take your own rugged tablet that you might already have, a larger Surface Pro tablet, or even your phone. We have an option for that to click this camera onto the back. Same calibration, same camera, so the data itself is going to be the same. But it's only a $995 camera, so it's less than half the price of a DPI kit, not much more than a RealSense, and available in either the short or long range model.
What kind of tablet? I mean, do you recommend the latest Surface or whatever? What kind of Windows based tablet are you sort of recommending?
Yeah, so we are fully supported on both Windows and Android. In the Windows world, We've had a lot of success with the traditional Surface Pro tablet, or what we carry for our DPIs and can make available for RealSense kits is called the Surface Go, or the Surface Go 2 in this case. And it's basically just a compact, very powerful version of a Surface Pro at an even lower price point. So it really just makes a lot of sense with what we do in terms of form factor and capabilities. We recommend a tablet with a minimum of 4 gigabytes of RAM, although an 8 gigabyte RAM tablet like this is preferred because it'll avoid any sort of scene size limitations as you move through your scene. On the Android world, we are typically deploying these days on a Galaxy tablet, so the Galaxy Tab S6 or Tab S7, and also phones across the board. So I have my Galaxy Note 20 Ultra, an incredibly effective and powerful phone. We've also tested on the S20, the S21 series, and had some really successful results even on, even more affordable Android phones such as Motorola or Google Pixel options.
Yeah, I think that's something else I think that's really important here is that this is working on your phones. And I think that the fact that, there's no, at least as far as I've seen, the performance is actually pretty good. Like I can scan with this, and I mean,
it's kind of the way of the world nowadays. I mean, your phone is as powerful of a computer in many cases as your computer itself.
Yeah,
so,
for sure.
Especially for software that was originally designed for a mobile platform, first tablet based and now porting over to phones. The phones are at least as powerful as the tablets, so it makes sense.
Yeah, let me ask you about the software, because I mean we're kind of talking about it. You mentioned a couple of things, and I can see on the website here you've got Dot3D Pro, Dot-X, and Dot3D Lite. Maybe very quickly go through the maybe some of the differences, but I do want to focus on the 3D Pro.
Absolutely. So yeah, and most of our customers, most of our use cases are gravitating towards Dot3D Pro. It's our flagship 3D capture solution. It includes virtually all of our capabilities, no scene size limitations, no export limitations. That's the full package. However, we do offer these lower tier solutions that for the right project needs can be a really nice fit and can sometimes make the software more deployable in a larger industry, kind of trying to give options to put this in more people's pockets. So the Dot3D version, this is a very powerfully affordable, but also capable version in that it's almost entirely the same as Dot3D Pro. It includes all the same functionality, no scene size limitations, but it doesn't include export. So if you're trying to get into a CAD program with this data, if you are trying to register with another tripod data set in a third-party tool, you're always going to have to go for the Pro version. But if you're just trying to document an entire scene in 3D, mark it up, take measurements and share the data within the Dot3D environment, then you can do that all in Dot3D Lite. Sorry, correct myself, Dot3DX. And this is kind of the second tier down from Dot3D Pro, but it goes from $995 a year for the Pro version to only $395 a year for the X version. So if you're happy, sharing your data and working with it for measurement, visualization, and annotation purposes within Dot3D, then Dot3DX could be a way to go. And we see this as an option, for more police departments, at the small department scale, to get into 3D capture, and not necessarily have to even work with more complex downstream workflows. Just measure, share, view, and annotate to pieces of evidence in the scan.
You also, you also offer the ability to scan April tags, and you have there's a scale bar and things like that. What can you tell me about the accuracy of using the April tags, and what kind of features do you have to help improve the overall accuracy?
Absolutely. So here's what we're talking about. These are some very convenient magnetizable 3D printed version, but they can also be just printed out on paper. And these are a set of unique tags that are recognized automatically by Dot3D, and they will automatically improve the accuracy of your data. This is especially relevant for larger area scans. It is optional. Our data is, very accurate in its own right, especially with best practices being taken for small scenes or a single small room. But in any case, the April tags are always going to automatically improve upon that. So they are always recommended. And what they're doing is basically you start at one of these tags, or ideally multiple of them, and you move throughout your scene. You finish back at those tags, or loop over them as you see fit throughout your scene. And every time they're recognized more than once, it'll lock in on that point during the optimization and say that if for some reason those points were off by, a millimeter or 3 millimeters, they're not going to be off at all. They're going to be exactly aligned with each other. And that makes every single other point in your scene a little bit more accurate automatically. They're also very convenient in terms of their ability to be utilized for scale distance references or known coordinate references. So what you see here is a custom kit built by our partners at Brunson Instrument Company that leverages these tags, and it has custom software built into Dot3D where you put these bars in your scene at any combination. So you see there's 6 bars. It could be 1 6-meter bar if it's a long stretch of pipe you're scanning, or if it's a traditional room, you could have 3 2-meter bars on length, width, and height. And Dot3D knows instantly, just by putting those in the scene, that that's an exact reference measurement, and it will guarantee that your data is fit precisely to those measurements. It can be done with a custom hardware kit like this. It can also be done by putting a couple tags on the wall and taking a tape measurement between them, and you can reference it that way as well. Yeah, lastly, if you have known coordinates in your scene from another scan, it can be utilized to register your data set to a larger scale scan or to another Dot3D scan.
Yeah, no, I've seen, I mean, the software, I have to say, like one thing that's always impressed me about the software is you're taking like way back from the PrimeSense, because I've used so many different other programs, but what you guys are doing with these low cost sensors is really phenomenal. I mean, is really impressive. And I think that's probably the biggest thing. Like, you're getting really good quality data out of these low cost sensors, and much better than any other sort of program and stuff that I've seen. So I think that's really a testament to what you guys are doing. The software also, I mean, is really comprehensive. You also have the ability, I believe, like there's things you can do where, for example, as you're scanning, you can annotate or like take, I believe you can take photographs and stuff, can't you? Like what can you tell me about some of the other little features that are in there for enhancing the scan?
Exactly. So you can, as you're scanning, I can maybe even pull up a scan to show some of this. You can capture HD photographs. So this is leveraging the fact that our tablets and phones nowadays have some really high resolution, excellent cameras built into them. And the 3D cameras themselves, maybe 720 or 1080p, depending on which camera you're using, but not nearly the level of high resolution that you can get out of a tablet or phone camera. So while you're scanning, you can just press the take picture icon. And what it does is it actually captures a photo from that position and then brings it up in Dot3D when you open up your scan. So you can see where you were standing when each of those images were taken separately. So this has the benefit of showing that position and trajectory. But oftentimes, a crime scene unit or a police department is obviously still going to be taking their traditional crime scene photos as well. The nice thing is those can also be attached in as annotations to any particular 3D point. So you have both options at your disposal. The other thing you mentioned was the ability, as you're scanning, to flag a piece of evidence or anything that you want to add a note to. You have a crosshair on your screen, and you just press the scan time annotation button, as we call it. And that adds a mark to that point in 3D. And when you finish your scan, it'll prompt you to fill in the details of that particular piece of evidence or piece that you want to annotate to. And those fields are all customizable too. So if you have a specific set of fields you want to be filled out by your users, you can customize those fields for each deployment.
Oh, that's awesome. Just a couple more questions. So one of them is, what can you tell me about the development, or is there anything you can say at this point? I always like new information if it's possible, without giving away any of the big secrets. But are you guys working on anything new? Are you guys working on anything exciting? I don't know if you can say anything, but if not, just whatever you can tell us.
So absolutely, and I can say some things, and I can't say others. But in general, we are always working on something new. I really like what you said about how we are, trying to leverage as much as possible out of low cost and increasingly powerful cameras, and increasingly varied cameras too. So we're seeing, not just in the RealSense world, but outside of it, there's more and more cameras popping up that each, excel in different ways. And our goal here is to be the single most powerful application that you can have installed, and then plug and play each camera as you need, or depending on your needs, purchase one specific camera for what you need. So that being said, we are working on new cameras that we hope to come out with in the relative near term. The one that we are actively working on and excited about is the LiDAR camera that's built into the latest iPhones and iPads. So this is, going to be a little bit different than the active depth cameras that we've utilized for high density accurate point clouds to date. But it's built into phones and iPads, and we're looking forward to releasing a version of Dot3D on there as well. So please stay tuned on that front, as well as other cameras coming soon.
Oh, awesome. Well, I'll tell you what, I think the only other thing that came to mind, I thought it would be really cool if there's a way that maybe we can show people some of the data. And maybe I can even do that afterwards, like offline. But if there's a place where we can fish out some data, and it would be interesting, I don't know if you have any data sets that are comparing like the 415, the 455, and maybe the L515.
I do. So let me, I was actually just, as we spoke, pulling up a data set and doing some cropping on it. But, sorry, my screen wasn't sharing. But let me just pull up another page.
Yeah, while you're doing that, I'll mention if anyone wants to check out the products and that sort of thing, just go to dotproduct3d.com, and that's where you can find out some more information.
And dotproduct3d.com/comparison data here is where we have the same room, a mechanical electrical maintenance room from our office in Boston, utilized as a very solid sample scan that could be applied to a lot of industries. It could be the scale of an interior crime scene. It could be an electrical maintenance room in utility world, or a room on a ship. And it basically was scanned with each of these different cameras that we talked about today, every single one. You can download the data directly and open it up in Dot3D, which is available with a totally free version for viewing data, and a 7-day free trial with all the pro features included.
Oh, that's awesome. Well, I think we'll cut it there, Chris. Oh, you got some data up there. Actually, no, we're not going to cut it here because I want to see this.
Yeah, sorry. I just powered it up a couple minutes ago, and I thought my screen was sharing, but here is a data set captured of a floor of a house, in this case with a DPI-X camera. Yeah, take a look. So this was
which sensor was this?
This was the DPI-X, and we will be releasing this data set. We basically did an entire house similar to what you were just describing, to show where each camera benefits. So essentially, you see this kitchen has 1, 2, 3, 4 April tags in it.
Yeah.
And we did the first floor with the DPI-X. Then we went from the kitchen down the stairs here into the basement, did the entire basement with the L515, where it excels, where there's no window light, or at least minimal. And then we went through the front door of the house here, and did the entire exterior of the house using the D455.
Okay. So when you say sorry, just to back up, when you say it was the X, that's the PrimeSense sensor?
Yes, it is. Exactly. Okay. So that's just the new modular model of the DPI-10. So this could have been the DPI-10 or the DPI-X. The data would be the same either way. And if I go to view high-res photos, just to show what we were talking about earlier, you see that there was an image taken while scanning in Dot3D of the, oops, sorry, my mouse is acting up on me, of the dining room here. And if I click on it, it'll bring me there in 3D. But if I hold on it, it will bring me there in 2D, where you get a much higher level of 2D resolution. So you can take as many of those photos as you want, and you kind of walk yourself through the scene to see the photographs.
That is cool. That is cool. Yeah, and just yeah, I would recommend if anyone wants to try this out. Do you have like a demo, or like if somebody signs up, like what do you have that they can play with?
Yes, we do. So if you just go right to our website, and it pops up a lot of other places too, but in the subscribe to Dot3D tab here, you have all the different options. But first thing you see here on the left is Dot3D free. You'll notice that Dot3D free also includes a 7-day trial of Dot3D Pro. So just follow the steps to download and activate here, and you'll be all set. If you have a camera, you can start scanning. If you want to just look at data, you can use it for that purpose as well. and it'll allow you, the free version forever to read in DotProduct data, take a look at it, see 1 or 2 measurements, etc. And then when you're ready to subscribe, you have all the different options here.
Oh, that's excellent. So Chris, if somebody wants to get a hold of you or they have some questions, is there a place that they can reach you on, like on LinkedIn or through the website, or what's a good place to reach you?
Definitely. So you can reach me directly. If you have any questions specific for me, I'd be happy to help. My email is chris@dotproduct3d.com, or you can go straight to the website and just go to our contact us page and somebody will be in touch.
Excellent. Chris, thanks a lot for the information. I appreciate it always. You're always really helpful. Great workshops at conferences. Maybe one day we'll be back at conferences in person again. Hoping for that.
Seeing you in person again sometime, hopefully soon.
Yeah, hopefully soon. But yeah, no, I appreciate all the insight, and hey, keep doing you guys doing just really great work. So keep it up and really enjoy the product. Thanks a lot.
Thank you.